Hello all, welcome to tonight's video, which is a review of radicals. These notes are not in your packet, so you're going to have to do this, take these notes either in a notebook or on a separate sheet of paper. Just to look at the objective, we're going to simplify radical expressions. This is something that you already learned in algebra, but we're going to do it again because we're going to need this skill later in the chapter. Okay, so first thing is I want us to write down the first 15 perfect squares. So I'm going to give you a few examples. 1, 4, 9. 1 is 1 multiplied by 1. 4 is 2 multiplied by 2. 9 is 3 multiplied by 3. 4 multiplied by 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. You should have these memorized. Normally when we're going to be simplifying radicals, you will not be permitted a calculator. So you need to memorize these 15 perfect squares. Remember, at any point in the video, if I'm going too fast, you can pause or you can rewind. Okay, moving on, we're going to simplify perfect squares. So I need to think, what number multiplied by itself gives me 121? 121 is 11 multiplied by 11, so the square root of 121 is just 11. Okay, what number multiplied by itself gives me 64? 64 is 8 multiplied by 8, so the square root of 64 is 8. Okay, this next one I'm going to keep the negative 2. Then what number squared gives me 9? 9 is 3 squared, so the square root of 9 is 3. Negative 2 multiplied by 3 becomes negative 6. So that's my final answer. So those are the easier ones. Those are the perfect squares. We're not always going to have perfect squares, though. Simplifying a radical like this, 24. 24 is not a perfect square. So this is where we're going to write down some steps and then do this example. There are two ways to do this problem. I'm going to show you the way that I prefer, and then I'm going to show you another way that you probably learned last year. So the first step is to write out a factor tree. And these have to be prime factors. So remember, prime means the only number that it divides by is itself. So prime numbers are 2, 3, 7. Non-prime numbers are like 4, because 4 has 2 times 2. 6, 2 times 3. Whereas those ones I mentioned before, 2, 3, 7, the only factor of 2 is 2, and then 1, of course. 3 is just 3. 7 is only divisible by 7. So breaking down 24, 24 is 4 multiplied by 6. 4 is 2 times 2, and 6 is 2 times 3. Second step is to circle any pairs of prime factors. So here I have one pair of 2's. The 2 and the 3, they don't have a pair. They don't have a partner. And the last step is to simplify. Okay, 1 in the pair comes outside the radical. So 1, 2 comes outside, we just forget about the other 2. The numbers that don't have pairs or don't have partners go inside the radical. So the 2 and the 3 go inside the radical. 2 multiplied by 3 is 6. So root 24 is the same as 2 root 6. Okay, so that's one way to do the problem. What I'm going to do now is I'm going to erase it, and I'm going to show you the other way. We're not going to write out the steps, I'm just going to show it to you. So again, this first way is the way that I prefer and that I do the problems. If you want to do it this other way, that's fine though. Okay, so the other way is to look for a perfect square. So what perfect square goes into 24? So you got to think about all those numbers we wrote down at the beginning. 24 is 4 and 6. What is the square root of 4? Well, the square root of 4 is 2, because 4 is 2 multiplied by 2. I can't simplify root 6 anymore, so it becomes 2 root 6. Notice you should get the same answer either way. This second method is faster, but you really have to know your perfect squares really well. If you're not so good with numbers are perfect squares, the first method was a little easier. Okay, so I'm going to start with 63, root 63. 63 is 9 times 7. 7 I can't break down. 9 is 3 times 3. 3 times 3 is a pair. One member of the pair comes outside. Forget about the other one. This 7 is left over, so it stays under the root. So root 63 is the same as 3 root 7. Then I have root 88. 88 is 8 times 11. 8 is 4 times 2, and 4 is 2 times 2. I have one pair of 2's. I have a 2 and an 11 left over. 1 2 comes outside the radical. The other one we forget about. Under the radical, the 2 and the 11 are left because they don't have partners. This becomes 2 root 22. So root 88 is 2 root 22. Right now I would like you to pause the video and do root 72 on your own. When you come back, I will give you the answer, but I will not show you the work. Okay, hopefully you took a chance to try this one on your own. You should have gotten 6 root 2. Again, you can use either method, I don't care, but you should have gotten 6 root 2 either way. Multiply and square roots. Anytime you're multiplying, you multiply the numbers outside the root, and then you multiply the numbers under the root. 5 multiplied by negative 2 is negative 10. 6 multiplied by 6 is root 36. Now we need to think, root 36, that's a perfect square. What is the square root of 36? Well, 6 multiplied by 6 is 36. So the square root of 36 is 6. So negative 10 multiplied by 6 is negative 60. That's my final answer. And then we are finished for this video. First example, I can multiply numbers outside the root and the numbers under the root. 4 multiplied by 7 is 28. 3 multiplied by 15 is 45. Now I need to break down that 45. 45 is 3 times 15. 15 is 3 times 5. Here I have a pair of 3's and a leftover 5. So I still have my 28. 1 3 comes outside from the pair. We forget about the other 3. And the 5 stays under the root. Okay, and then 28 multiplied by 3 is 84, and I keep the root 5. So that's my final answer. You have one more to do on your own. You have this 2 root 7 squared. Remember that when you're squaring something, you're multiplying it by itself. So this is 2 root 7 multiplied by 2 root 7. Pause the video right now. Try this one on your own. When you come back, I will give you the answer, but I will not show you the work. Okay, hopefully you had a chance to try this one on your own. You should have gotten 28 to be your final answer. If you have any questions or you're confused at all, bring those questions to class and we will answer them. Simplified radicals. So we simplified the perfect squares, we simplified the radicals with the factor tree, and then we also multiplied the radicals. When you come to class, we're going to be doing some practice with this.